morning to everyone. Today we will present about memory and interface to memory. Okay. Memory. Each memory device has at least one chip, select CSO, chips enable, we call it CE, or select as pin that enable the memory device. This enable read or write operation. Memory type. There are 4 memory type. It is type. There is a ROM. ROM means read only memory. Type memory that does not lose its contents when power is turned off. Okay, there are 3 types: PROM, EPROM, and EEPROM. PROM means programmable ROM. EPROM, erasable programmable ROM, and EEPROM, electrical erasable ROM. Okay. Next, we're gonna talk about RAM. RAM is called a volatile memory since cutting off the power to the IC will mean loss of data. Okay, there are 2 types of RAM: SRAM and DRAM. SRAM is a static RAM and DRAM is dynamic RAM. Next, we discuss about the interface. What is an interface? An interface is a concept that refers to a point of interaction between components, and it's applicable at the level of both hardware and software. This is the example of block diagram. It has memory, address line, data line, control line, interface. And the next example is 8085 interfacing pin. In 8085 interface pin, we had higher address bus, lower address or data bus. 8085 address bus used to address memory and input-output device. 8085 has a 16 bits address bus. Data bus is used to transfer instruction and data. 8085 has 8-bit data bus. Okay. For the highest order address, the higher order address has bus is a unidirectional bus. It carries most significant 8 bits of a 16 bits address of memory or input-output device. And the address remain as line as long operation is not complete. It's only in higher order address bus. So the last one, lower order address bus or data bus. This bus is bidirectional and works on time division multiplexing between address and data. During first clock cycle, it serves as a least significant 8-bit of memory input-output address. And 4 second and 3rd clock cycles, it acts as data bus and carries data. Okay, that's all for me.
Hello, good morning. I'm Morgana. I would like to present about the memory interface. So, the memory is made up of a semiconductor material used to store the programs and the data. The types of the memory has divided by 2, which is known as primary and secondary memory. The primary memory is also known as the main memory. And the primary memory, RAM and ROM are the examples of this type of memory. So microprocessor used in is storing a program temporarily, which is known as the commonly called loading, and executing the program. Hence, the speed of this type of memory should be fast. The secondary memory these are used for the bulk storage and data and information. The main examples include floppy, hard disk, CD-ROM, magnetic type, and etc. And also it is slower and sequential access nature, and also it is a non-volatile nature. Thank you.
Very good morning to all of you. My name is Shashali. I want to represent about the types of address decoding. Okay, so I want to discuss about types of address decoding. There are two types of address decoding, which is exhaustive decoding and partial decoding. So partial decoding is in this scheme minimum number of address line are used as you can to select a memory location chip. There are advantages and disadvantages. Advantages are simple, cheap, and fast for partial decoding. However, disadvantages is unutilized space and fallback, which is multiple mapping. Second is bus contention and different feature expansion, difficult feature expansion. Data can be transferred between the microprocessors and the outside world. That can be done in groups of 8 bytes using the entire data bus. It is called parallel input and output. The other method as serial input and output, where bit is transferred a time using in SID and SOD pins on the microprocessors.
Assalamualaikum and good morning. My name is Fazni Aidil and I will tell about parallel interface. There are types of parallel interface. There are two ways to interface 8085 with I/O device in a parallel data. Transfer mode F2, memory mapper I/O and I/O mapper I/O. Memory mapper I/O is considered them like any other memory location. They are assigned a 16-bit address within the address range at the 8085. The exchange of data with this device follow the transfer of data with memory. In I/O mapper I/O is treat them separately from others. I/O device are assigned a port number within the range of 00H to FFH. The user in this case will access this device using the in and out instruction only.
Assalamualaikum and good morning. My name is Nurina binti Muhammad Asri. So today I'm going to present about differences memory input output. So for input output map to input output, first input output is treated as memory, 16-bit addressing, and more decoder hardware can address 216 to 64 locations. Less memory is available and memory instructions are used. Memory control signals are used. For input output map to input output, input output is treated as input output and 8-bit addressing. Less decoder hardware can address 28 to 256 locations, and whole memory address space is available. They have special instructions are used like in and out, and special control signals are used. So that's all. Thank you.